An Introduction to Science Olympiad Vehicle Events by Haram Ritbal and Pradyumna Kala.
What you'll learn from this video. The first thing that we'll go over is understanding the wheeled vehicle and scrambler events themselves. We'll gain insights into the objectives and requirements of the wheeled vehicle / scrambler event in Science Olympiad, and take a look at the rules and requirements that need to be followed. The second thing we'll go over is the design process overview. We'll learn about the brainstorming and design considerations for creating a successful wheeled vehicle and scrambler, and discover how to transform ideas into practical designs and the importance of planning. The last thing we'll do is testing and optimization. We'll watch the testing phase of the vehicle and how to make adjustments based on performance. We'll also learn about the iterative process of refining your design for optimal results.
So our experience in vehicle events. In 2023, we competed in Mira Loma Science Olympiad and placed 5th in wheeled vehicle. We also competed in the San Joaquin Regional Tournament and placed 2nd. We also competed in the NorCal State Tournament and placed 1st for wheeled vehicle. In 2024, as our first year in Division C, we placed 5th place at the Berkeley Science Olympiad Tournament. We placed 3rd at San Joaquin Regionals. And at NorCal States for Scrambler this year, we placed 6th. We also placed in a whole lot of events other than vehicle events. We have a lot of experience in Science Olympiad in general.
What is wheeled vehicle? Wheeled vehicle is a physics-based build event in which students must construct a vehicle powered only by a non-metallic elastic solid device, for example, a rubber band or a latex tubing. The participants must be able to adjust the vehicle to travel a specified distance as chosen by the event supervisor as fast and as accurately as possible. Depending on the year, you may either be asked to make the vehicle travel straight or in a curved direction between two cans. In either scenario, there's a start point and an end point. The ultimate objective is to get as close to the endpoint as fast as possible, so you need accuracy and speed. To do this, precise braking, effective energy propulsion systems, and steering, especially when there's a curve required, is required.
So what is Scrambler? So using the 2023 to 2024 rules, because the official 2025 Division B rules haven't been released yet, teams have to design, build, and test a mechanical device which uses the energy from a falling mass to transport an egg along a straight track as quickly as possible, and also stop as close to the center of a terminal barrier without breaking the egg. The maximum mass and height of the launcher will vary by year. In the 2023 to 2024 cycle, the maximum height was 100 centimeters and the maximum weight for mass was 1.5 kilograms. And you can see in this diagram, this is a common type of scrambler launcher that is used. This is called a hammering system. So you basically drop the weight and it pushes your car forward.
Gathering materials. Before you start building, it is important to make a list of materials that you will need. Just keep in mind that the vehicles need to travel as fast as possible and also be accurate at the same time. Here's a list of things you need to consider. You need to consider a frame, the wheels, the axles, the braking system, the dimensions, and what is holding the things together.
So for frame, in both wheeled vehicle and scrambler, speed is a big part of your overall score. And this means that minimizing weight in your frame is crucial because a lighter frame will allow your car to travel faster, which will improve your score. However, it's also important to make sure that your frame has structural stability as well. So the key to strike a balance between the two is to use materials that have a very high strength to weight ratio. So lighter materials that are very strong are ideal rather than using weaker materials like wood or strong but very heavy materials like stainless steel. And a good material to build your frame out of is carbon fiber. Carbon fiber is an incredibly strong material despite being very light, and many competitive teams use it to develop their frame. Another potential route you could take is 3D printing, which lets you develop detailed custom designs in case you need that.
Wheels. When considering the wheels needed for your vehicles, you want to look for the weight and traction of the wheels. You want to make sure that your car can stop as quickly as possible and not skid at the same time. In the beginning of our build process, we thought RC racing wheels would be a good idea because of how light they are, but they lacked the traction needed to stop quickly. We eventually found our way to Bainbot wheels, and they gave us the traction as well as the ideal weight we needed. Bainbot wheels come in many sizes and forms, so it is up to you on what size suits your needs. So Bema offers three types of wheels, and you can differentiate them by color. Green wheels offer the most traction, but they're also not very stiff. Orange
Yeah, they're
wheels,
very not durable. They have
yeah,
the least durability.
orange wheels are not as they don't have as much traction, but they're a little more durable and more stiff. And blue wheels are they have the least traction and they're the most stiff and durable. So these are things that you might want to consider for building your vehicle.
So axles in your vehicle, role and function. So for support and rotation, axles are a crucial component in your wheeled vehicle, as well as your scrambler. They provide support for the wheels and enable them to rotate smoothly. The axle transmits power to the wheels, which allows your vehicle to actually move. So when deciding what materials you use for your scrambler, I mean for your axle, you need to use the same general rules that we discussed about in the frame. Those rules still apply. In this case, however, using steel may be a better idea due to its strength and the fact that axles in general are fairly thin, so they often do not contribute as much to the total weight of the car. So thickness and diameter. The thickness and diameter of the axle should be chosen based on the expected load and stress. Thicker, wider axles are generally stronger and more resistant to bending or braking, but they also add weight to your car. Many teams choose to brake on their axle by having threaded rods as their axle and then using a wing nut braking system, which will be explained in the braking slide shortly. Make sure you pair your axles with ball bearings to reduce friction, and you have to ensure that your axle fits in snug with these bearings.
Another thing that you could use, but if you don't have ball bearings, is graphite powder. And graphite powder basically makes the axle spin more smoothly within the
Within its
chassis.
slot. Yeah.
Yeah. Braking system. The wing nut can be used on either the front or the back of the on either the front or the back axles. As the vehicle moves, the wing nut can be manually turned. Turning the wing nut causes it to move along the threaded rod or bolt. When the wing nut reaches a predetermined point on the rod or bolt, it can come into contact with a part of that vehicle. We use two bolts stuck in place on the axle as our stopping point. And during calibration and testing of the vehicle, you experiment with setting the wing nut back to a certain number of turns for each target distance. These values are then put into practice logs so that they can be repeated at the competition. And you can see a diagram of how that will look like on the right.
So dimensions of your car. The maximum dimensions of cars will be specified in the Science Olympiad rules, and that may change depending on what year you're competing in. Dimensions can play a role in the speed and structural stability of your car, however. Some teams may opt to go with wider dimensions, while others may have smaller dimensions and thinner cars. Most often, you will see bigger variances in the width of cars rather than their length. So thinner cars with a smaller width, which or can be useful for turning or going in between objects. Meanwhile, wider cars are harder to turn and travel straight more effectively.
What's holding everything together? In our car, we used carbon fiber rods for our main frame, and we 3D printed the pieces to connect them together. At first, we used Tinkercad for our 3D modeling, but this may not be possible for more complex prints. I would advise using Fusion 360, and it is also free for students. It is also important to consider the different type of filaments when 3D printing. In our case, we use PLA as it is the easiest to use and consider the starter filament. In this table, you can see how each material compares and the different strength, flexibility, and the concerns of each material.
So gathering materials for your launcher, and this is specific to Scrambler. Before you start building, it's important to make a list of materials that you will need. Just keep in mind that the launcher needs to store the maximum potential energy possible and transfer the most that it possibly can to the vehicle. So you want to build your launcher out of sturdy materials. There's no benefit of having a lighter launcher, except maybe transportation or carrying it, so heavier is usually better. Wood or thick aluminum bars are typically used to build launchers, and we recommend you use either of those materials as well.
The launcher mechanism. There are several types of launcher mechanisms you can explore. The most common one and the one we recommend to you is the pulley launcher. As you see in the diagram, there's a loop of string connected to a piece of the car. This string runs through the launcher by going through two pulleys and is also connected to the weight. As the weight drops, it will pull the string down, which then results in the car being pulled forward. In our design, we used a latex tube and a stopping mechanism. The car didn't move until the latex was stretched and the weight was at the bottom. Doing this increases the speed. We took inspiration of this from Unfazed, who is a fellow Science Olympiad YouTuber.
So, this is a continuation of our launcher mechanism for Scrambler. So to maximize the amount of energy being transferred to the vehicle, you want to increase the height of the launcher to 100 centimeters and maximize the weight to 1.5 kilograms. By this, what we mean is that every year there's specifications on how tall your launcher can be. Ideally, you just want to max it out. So if the max is less than 100 centimeters, you obviously don't want to go over. Just meet the maximum requirements. That's generally best. So remember, force is mass times acceleration. Since the mass weighs 1.5 kilograms in our case and is also falling faster to the ground than a lighter mass, there's more force generated, which makes your car travel faster and with more power. So in our launcher, we also use an elastic material in our string. So tools need to put everything together. Oh, so we use a 3D printer, screwdriver, drill, washers, nuts and bolts, and super glue. These are all just parts that we use to connect the pieces of our launcher and actually give it structure.
The rubber mechanism for the wheeled vehicle. So the latex tubing is usually hooked onto an axle using string and placing a small hook on the axle. You create a loop with the string, hook it onto the axle, and then wind the axle back to stretch out the rubber band. At this stage, you need a stopping mechanism for your car to hold it in place until you're ready to release the band. This can be a sort of trigger that blocks the hook until it is released. Once released, the rubber band will suddenly pull back together, pulling the axle with it and then moving the car. The car on the bottom right was our final car for wheeled vehicle, and it placed first in NorCal states. As you can see from our original model, we switched to Bimba wheels and we made the car thinner than it used to be.
So why should you use elastic and string? And this is specifically for your Scrambler launcher. Elastic materials can store potential energy when stretched or compressed, and this potential energy will then be converted to kinetic energy when the mass is dropped and the elastic is stretched. The release of the energy will also be smoother when using an elastic as compared to a rigid string because of the more controlled and predictable movement. Tension of the elastic material can also be adjusted, and increasing the tension can lead to increased force applied to the vehicle. So the way you do this is to increase tension, you'd maybe have a shorter piece of elastic material, and that would force it to stretch more. So for our elastic, we had a latex tube with a piece of string on each side. However, I would also recommend testing with an elastic string itself because it'll provide a more consistent release of energy compared to a mix of string and elastic material.
How to curve. In some years, you will be asked to curve your vehicle by making it go around an object or between two cans. As you can see in the diagram below, the entire front axle piece is connected to the body by through a screw and a nut. You can see it right here, as well as two side pieces for stability right here. By loosening the screws, you can adjust your front axle to change the angle and then tightening them again. And this idea was also inspired by Unfazed.
So testing/optimization. So your initial wheeled vehicle or scrambler design is built. The next step is to now test. It is specified in the rules the range of your target distances as well as the increments in between them. So you should now test your vehicle for each individual target distance and see how close you're getting to your targets. If you are happy with how close you get as well as your speed, then that's great. If you aren't so happy with the results you're getting, it's time to iterate over the design process. Think about what the problems with your current design are and why it isn't doing well. Brainstorm and design a solution to these problems and then implement the solution.
Thank you for listening and goodbye.
Bye.